Let's say you're given a vector field and you're trying to integrate this vector field around this rectangle starting from 3 comma 0, 3 comma 2, and then negative 3 comma 2, okay, all the way here, negative 3 comma 2, and then negative 3 comma 0, and this, okay? So you're trying to do this line integral, and one way to do this would be actually to parameterize all these curves, C1, C2, C3, C4. So the question is asking us to calculate over this C1 plus C2 plus C3 plus C4 of this vector 5 times x plus y plus I vector plus 8 sine y j vector dotted with dr. That's what this question is asking. And already this is something that we wouldn't want to do because you have to parameterize 4 lines and you have to do 4 integrals. That's a lot of work. So is there a better way? Well, the better way is to see that this is going counterclockwise around this region R, right? So that means we can make use of the Green's theorem, which says if you have a path that's bounding a region, and if it's going around the region counterclockwise, then you're in luck because p dx plus q dy, the line integral, actually this is just same as f dot dr, where f is pi plus qj. Okay, it's just written a different way. Okay, so if you had to do this, which is exactly the case what we have here, then all you have to do is do a double integral over the region R of this quantity. Okay, and this is a two-dimensional curl. Okay, so let's see. So let's do that integral over R of differentiate by x, differentiate by y of 5x plus y. Actually, let's rewrite this as 5x plus 5y. That'll be easier to calculate. And then sine of y, 8 times dA. And then how do you calculate the determinant? It's AD minus BC, right? So boundary of x hits 8, partial derivative of x hits 8 sine y, and then minus the partial derivative of y hits 5x plus 5y. And then you have to do this double integral, dA. Now partial derivative regards y as a constant, so even if you have 8 sine y, when you differentiate by x, that's just 0. And again, if you differentiate by y, x is considered as a constant, so 5y differentiated by y gives you negative 5. Okay, so you have negative 5 integral of r dA, and since this is negative 5 integral of 1 dA, that's like negative 5 times the area. But what is that? This length here is 6 and the height is 2, so the area is 12. So negative 5 times 6, negative 5 times 12 is what you get, which is negative 60. And that is the answer.